Quick, graph y equals a sine of the quantity pi over 2 times x by hand 2 different ways. This is part of the family of functions series. You will need paper and straight edge, and we suggest you create grids similar to the ones at the right as needed. Press pause as needed anytime during this video. The first way is with the sine dance. Recall the graph of y equals a sine of x, one period or wave, and notice the 5 key points of interest. These key points and all points are affected by the parameters in the equation, namely the pi over 2 times x inside the parentheses. That coefficient of x, which we usually name the letter b, is equal to pi over 2. It affects the width of the period inversely. The horizontal dilation factor, you may recall, is the reciprocal of that value for b. Or in this case, the reciprocal of pi divided by 2 is 2 divided by pi. Period of the sine function is normally 2 pi. For y equals a sine of the quantity pi over 2 times x, the period is going to be 2 pi times the reciprocal of b, which in this case is 4. Pause is needed. The period is 4. That's not 4 pi, notice. Remember that. We need to use a different scale now along the x-axis. We suggest marking off every unit from negative 5 to positive 5 along the x-axis. Pause to do that. You can see we did just do that. The initial point is normally at the origin, and it's unaffected by that factor of pi over 2. So we'll plot the origin. The end of the period is normally at 2 pi 0, but this one is affected. It's going to be at the end of the period, which is 4, at 4, 0. Halfway between is another point of inflection, and for us, halfway between will be a point of inflection at 2, 0. Halfway between the first 2 points of inflection is a maximum, so for us that will also be a maximum, in this case at 1, 1. And halfway between the second 2 points of inflection is a minimum, and that for us, that you can see that's going to be at 3, -1. Pause is needed. Connect the points as a sine wave, concave down and then concave up. But we'll plot one more period to the left, so we'll go back a full period, which is 4 units from each point, especially the key points of interest, and connect them as a sine wave. Frown, smile. Pause is needed. A generalization, the period of a sine wave is normally 2 pi. But what about the period of an equation of the form y equals a sine of the quantity some constant b times x? Since b affects the period inversely, the normal period is multiplied by the reciprocal of b. That is, the period for y equals a sine of the quantity b times x is 1 over b times 2 pi, which is the fraction 2 pi divided by b. So the period is 2 pi divided by b. This is a big deal. You should write it down and remember it. Pause is needed. Let's generalize that here and apply it to these 3 specific cases. Do those 3, find the period of each, and pause until you're ready. So here the period's 2 pi divided by 3, 2/3 pi. Here it's 2 pi divided by 4, which simplifies to pi over 2. And here 2 pi divided by pi is just 2. Pause is needed. Second way is with a table. So we'll start with our axes values and ask you to complete the table. Pause to do that. And those are our unit circle values on the axes. We need to create a second table. The coefficient of x, which is pi over 2 inside the parentheses, affects the width or period of the graph inversely. So we're going to multiply each x value by the reciprocal of pi over 2, which is 2 divided by pi. So 0 times 2 divided by pi is 0. None of the parameters, that's the only parameter, does not affect the y value, so they remain the same. And so we start at the origin. I think we're going to hold off plotting those. Here we multiply pi over 2 times its reciprocal and get 1, comma 1. So we're going to need to change the units along the x-axis, and we'll do that once we complete the table so that we know how far we need to go. Then we'll plot the points. Pi times 2 over pi leaves us with just 2, comma 0. 3 pi over 2 times 2 over pi leaves us with 3, comma negative 1. And 2 pi times 2 divided by pi leaves us with 4, comma 0. We're going to change the units along the x-axis to go from negative 5 to 5 by 1s along the x-axis. Pause to do that. So we'll go ahead and plot the points, starting with the origin. 1, 1, 2, 0, 3, negative 1, and 4, 0. Connect them as a sine wave. We've got the concave down and then the concave up. We can plot another period to the left by going back a period, which would be 4 from each of the points of interest. In fact, all the points. And create another sine wave. Frown, smile. Pause is needed. Now you try one. Graph y equals the sine of the quantity pi over 4 times x. Use either method or both for the practice. And also tell us what the period is. Pause to do that. Our graph is here in green. You can see that the period is 8 either graphically or algebraically.